Good afternoon. Myself Gautam Paul.
Myself, Virinder Pawar.
Myself, Rishabh.
So today we are discussing about the estimation and the regression by cross questioning to one another. So let's start this discussion. So Virender, what is estimation?
As we see from the given images, estimation is the fine art of guessing. As what I learned from the estimation is that it is the approximate calculation, and we can say that it is a kind of judgment based on available evidences. For example, when we try to predict something or detect something, we have to create something which we called as model. Using this model, we have to develop some mathematical structure. We have to describe or capture a kind of generalized behavior of object so that estimation can be done. The, we can estimate the signal and system separately. When signal, we can estimate the unmeasurable signal and noisy signal, and we can also estimate the future signal. And in system, there are two systems which we can estimate. First is dynamic system and complex system. These signal and system, first we create it into models, and these models is the paramount thing here, which is essential for estimating something. The main the main application of this estimation is used in control problems. Now my Now I would ask the question to Gautam. What is the type of estimation?
So basically there are two types of estimation. First is the online estimation and the other one is the offline estimation. So in offline estimation, basically we are estimating the model, the collection of data during which the system is functioning, and the time when you are estimating the model is totally unrelated to each other. And in online estimation, when we are estimating the model, the collection of data and during which the system is functioning, and the time at which we are estimating the model is totally related to each other. So these are the basic definitions of offline estimation and the online estimation. Now I would like to ask one question to Rishabh. What are the applications of this area?
Thank you for giving me opportunity for answering that question, Gautam. The examples of the application of this area is the majorly in the control system, where we can design a controller for different types of things like in an adaptive manner, like if we are making some kind of missile like humming missile which can fix its target and hit the target by a moving target. So in that case, by there is a camera on the head of that missile which can locate the target, and by the angle that the target is moving, it can calculate its velocity and acceleration, and adaptively changes its position by minorly tweaking its throttle and other wings वगैरह. And it is also widely used in manufacturing sectors, where the calibration of the tools and to monitor whether the tools that is being processed on a process chain is uh, uh, is actually manufactured correctly or not, according to the calibration of the device. And it is also used in speech recognition, where we can recognize the speaker by its pitch, uh, and it is also used in communication system where the noise cancellation is the major portion of the application of that thing. Thank you. And I would like to ask a counter question to the Gautam. What is regression?
Okay, so basically, a regression is the relationship between the variables in which we use to predict the unknown value of the one variable for a known value of the another variable. And in regression, one variable is considered as the independent variable, and the other variable is considered as the dependent variable. So now my next question is to Virendra Pawar. What is recursive estimation?
Thank you, Gautam, for asking question. Recursive estimation. In a recursive estimation in probability theory and in statistics or machine learning, it is also known as Bayes filter. Bayes filter is generally a probabilistic approach for estimating an unknown in probability density function. Recursive over time using incoming measurements and the mathematical process model. The estimation, this recursive estimation is also used in robotics. It is an algorithm used in computer science for calculating the probability of multiple beliefs to allow a robot to infer its position and orientation. As base filter allow robots to continuous update their most likely position within coordinate system based on the most recent acquired sensor data. Now my next question is to Rishabh. Can you please explain the application of this area?
Thank you, Virendra, for giving me opportunity to answer that question. So, the applications of this field are majorly like adaptive noise cancellation, which is widely used in communication, and so how it works, like there is a true signal. Suppose you are in an auditorium and you have to record the piano artist or any artist who is playing the song. So here is the true signal. But when there is a auditorium, there is also audience, so that the noise is also is inevitable, and we cannot reduce the noise by just keeping them quiet. So what we do, we actually put a secondary mic in the audience, so where we get the noise samples, and the true signal which is infected by the noise is uh, is this, which is going to xt plus wt, which is going through the microphone 1, and the noise signal that we are collecting from the audience, here we can be collected through the microphone 2, and with the adaptive filter we can set the gains according to the control system. It actually measures the type of gain it requires to to exactly match the noise, and after that it just put the inverted signal of that noise, so that the output, which is z of t, is yt minus uh, w cap t, where we can have a noise reduced samples. Thank you.
So I would like to add some application in the areas of estimation. So the first application is manufacturing in tool condition monitoring. So in this, we can check the condition of the tool online by putting a sensor, and from there we can estimate what is the dimension of the tool. So, sir, so thus Second application is speech processing in speaker identification, in which we can monitor the voice of the speaker and estimate that who is calling. And the third application is communication, noise cancellation, and channel equalization. I would like to ask one question to Virendra. What is principal component regression?
Uh, Principal component regression is a regression analysis technique which is based on principal component analysis. More specifically, principal component regression is used for estimating the unknown regression coefficient in standard linear regression model. Principal component regression is used for extracting significant variables from the input data. Uh, the important variables from input that we can predict output based on the small set of variable with lesser parameter. There are some drawbacks also of this principal component regression. The drawback of principal component regression is that component with large eigenvalue in the input space are not necessarily significant for predicting the output. Second is the small eigenvalue component may be more correlated with the output. Now I would like to ask question to Rishabh. What is partial least square method?
Okay, so thank you for giving me opportunity to answer that question, Virendra. So, partial least square is just the advanced version of principal component, and it basically in this method, instead of finding the hyperplanes which have the maximum variance between the response and independent variable, which can be it can be find a linear regression model by projecting the predicted variable and the observed variable. As we can see in the slides, in the next slide, here, as we can see that in the left image, the points that are aligned in the maximum numbers are taken in a vector is taken in that direction, and in the right, basically we just track the maximum variance in that thing. Okay, so in the partial partial least square method, instead of doing that, finding the hyperplane of the maximum variable, uh, we find a linear regression model by projecting the predicted variables and the observed variable in a new plane, because both x and y data are projected in a new space. The partial least square family method are because the since partial least square method has a family, and it can be known as bilinear factor model, partial least square discriminant analysis also is a variant of is the variant used by the y in categories. Thank you.